HPLC. HPLC stands for High Performance Liquid Chromatography, but could equally well stand for High Pressure Liquid Chromatography. It is a device used for separating mixtures, either to analyze the mixture or to separate a required product from others in a reaction mixture. It can also be used to detect concentrations. The principle upon which HPLC works is the presence of two phases: a mobile phase, which is a solvent carrying the sample, and a stationary phase, which is powdered silica packed into a column. The mobile phase is composed of bottles which contain solvents that are mixed in different proportions to give a mixture, to yield a liquid phase of suitable polarity for separation being done. The stationary phase is packed into a column like this, which contains silica particles to which a hydrocarbon chain is attached, making this phase nonpolar. The difference between types of columns is the hydrocarbon chain linked to silica. Like paper chromatography, a liquid called mobile phase moves past a solid called stationary phase. In paper chromatography, stationary phase is composed of water molecules bound to the cellulose in the paper. The mobile phase carries the components of the sample among the paper at different rates. How fast a molecule moves depends on the relative affinity to both stationary phase and mobile phase. HPLC contains a pump, which pushes liquid phase at high pressure that may reach 1500 kPa, hence called high pressure liquid chromatography. It also contains a degasser, which eliminates air bubbles to maintain uniform pressure. Before injecting the sample, it must be filtered by this filter in order to remove solid and insoluble particles that may block passages in the device. The solvent also is filtered. To initiate the experiment, a known volume of the sample is injected into the device. Not more than 100 microliter can enter the cycle, otherwise the excess is disposed. Alternatively, some HPLC devices have an auto-sampler, which runs samples in order without any human interference. The pump forces the mixed solvents with the sample through the column. The solvent emerging from the column, carrying the separated components, passes into the detector. Here, a beam of ultraviolet light shines through it. This light is absorbed by all components of the sample. Time taken by the component to come out of the column, called retention time. It can be used to identify the component. When the detector reading drops, the component is coming out of the column and passing through the detector. In this experiment, the drug bergabaline in capsule dosage form was under dissolution rate test, where samples were drawn at specific intervals of time, and were tested in HPLC for concentration comparison with reference samples. The charts were as follows.